In the deepest hours of night, when the world slows its breath and the stars seem to draw closer, there are moments when the universe reveals its quietest secrets, not with fanfare or proclamation, but with whispers that only the patient can hear. This is a story of such a whisper, a tale of something that moved through our cosmic neighborhood like a shadow passing over ancient waters. The night sky has always known more than it tells us. Between the stars, in that vast emptiness, we so often mistake for nothing something stirred. Not suddenly, not with haste, but with the deliberate motion of a traveler who knows exactly where they're going. Astronomers first noticed it as a faint smudge against the backdrop of infinity, a visitor from beyond our solar borders. They named it 3I Atlas, the third known interstellar object to brush past our cosmic shores. But unlike its predecessors, there was something different about this wanderer, something in the way it moved, in the silence it carried. Most celestial bodies announce themselves with dust trails or spectral signatures, with the cosmic equivalent of footprints in fresh snow. But 3I Atlas seemed to move through the void as if trying not to disturb the silence. Some visitors don't need permission to enter our dreams. The detection came on an ordinary Tuesday. A blip in the data, a variance in the expected. The algorithm flagged it without ceremony. Just another potential object among thousands. But when human eyes fell upon the readings, something shifted in the quiet rooms of observatories around the world. There's a feeling scientists rarely speak of, a tremor of recognition that precedes understanding. They felt it then, as the first images clarified. This wasn't just another rock tumbling through the cosmic sea. This was something that seemed to know its path. Through the great emptiness between stars, across trillions of miles of nothingness, it had found its way to our doorstep with impossible precision, as if it had traced this route before. The void remembers paths that history has forgotten. Those first observers would later struggle to articulate what made this object feel different. Some spoke of its trajectory, too clean, too purposeful. Others mentioned the strange absence of expected emissions. But beneath the technical language lay a simpler truth. 3 Atlas moved like something that belonged, like something returning rather than arriving. In the days that followed, as more telescopes turned their gaze toward this wanderer, the feeling only deepened. Data flowed in, measurements accumulated, but the essence of what they were witnessing remained elusive, like trying to photograph the space between heartbeats. Science measures distance in light years, but mystery has no unit of measurement. What makes an object interstellar is not merely its origin but its story, the tale of cosmic winds and gravitational dances that launched it across the void. Every such visitor carries the signature of its journey, written in ice and dust and radiation. But 3I Atlas carried something else, something that made seasoned astronomers speak in lower voices when discussing their findings, something that made them check their calculations again and again, searching for the error that would restore the comfortable boundaries of the expected. They found no such errors, only the growing certainty that they were witnessing something that defied easy classification. When the numbers speak clearly but say impossible things, even scientists begin to whisper. As news of the discovery spread beyond specialized journals and into broader scientific circles, a quiet observation began to take form. It wasn't what 3I Atlas was doing that provoked wonder. It was what it wasn't doing. It wasn't shedding material like a comet approaching the sun's warmth should. It wasn't tumbling chaotically like a random fragment cast adrift. It wasn't reflecting light as expected or absorbing heat as predicted. It was in every measurable way both there and not there, present enough to track but absent enough to question. Like a thought at the edge of sleep, both vivid and intangible. It didn't come to be seen. It came to remind us that we were never alone. The shape first appeared as nothing more than a dim fleck against the cosmic canvas, barely distinguishable from the background noise that fills our universe. Patience revealed more. As powerful telescopes gathered precious photons that had traveled for untold distances just to tell us that something was there, something was coming. But as the image gradually resolved, confusion rather than clarity emerged. The object refused to conform to expected parameters. Where astronomers anticipated the irregular silhouette of a tumbling rock, they found something that seemed to shift between states of being. Some shapes exist between the words we have to describe them. Light curves told contradictory stories. At times, 3I Atlas appeared to have the albedo, the reflectivity of polished metal, sending back sunlight with mirror-like efficiency. Hours later, the same instruments would register it as nearly black, absorbing light like the surface of a dark ocean. Temperature readings fluctuated beyond the expected variance, as if the object were breathing in its own quiet rhythm. Seasoned observers found themselves doubting equipment that had functioned flawlessly for decades. Engineers recalibrated sensors and found nothing amiss. The inconsistency wasn't in our instruments, but in what they were seeing. Even the light seemed uncertain how to describe what it had touched. Rotation patterns, those reliable fingerprints of celestial mechanics, offered no comfort to confused scientists. Most asteroids and comets spin along predictable axes, their movements governed by the physics of their formation and subsequent collisions. Thrice Atlas seemed to dance instead, its rotational axis shifting in ways that suggested either an impossible internal complexity or a defiance of fundamental physical laws. Some researchers began to joke uneasily about the object having a mind of its own. The laughter that followed these comments never quite reached their eyes. Humor becomes our shield when wonder approaches the boundaries of fear. As observatories around the world coordinated their efforts, pooling data and resources, a disturbing pattern emerged from the collective findings. The object's dimensions seemed to fluctuate slightly but consistently, as if it were expanding and contracting with mathematical precision. Not dramatically enough to suggest disintegration or collision, but subtly enough to indicate something beyond our current understanding of interstellar matter. Senior astronomers reminded their younger colleagues that measurement at such distances contains inherent uncertainties. But privately, they pored over the numbers with growing fascination. The more we observed, the less we understood, as if the universe itself was hiding its handwriting. Debates intensified about what exactly we were seeing. Was it a fragment of some shattered world, carrying the elemental signature of a star system we would never know? Was it a rubble pile, a loose collection of rocks held together by the gentlest gravitational embrace? Or was it something solid, ancient and whole, a relic of processes we had yet to discover? Every new measurement brought conflicting evidence. Every new calculation added another layer to the mystery. In conference rooms and virtual meetings, scientists found themselves divided not by evidence, but by their willingness to consider increasingly unconventional explanations. When faced with the truly unknown, our theories become mirrors reflecting our deepest assumptions. Spectral analysis, normally the astronomer's most reliable tool for determining composition, returned readings so anomalous that some researchers suspected equipment failure. The absorption lines, those distinctive fingerprints that reveal elemental composition, flickered between recognized patterns and arrangements never before documented. It was as though 3I Atlas was composed of familiar matter, arranged in unfamiliar ways, or perhaps unfamiliar matter that occasionally resembled what we know. Either possibility stretched the boundaries of accepted. Astrophysics thought some visitors speak in languages that exist between the elements of our periodic table. As the object continued its silent journey through our solar system, the confusion it generated began to coalesce into a humbling realization. Perhaps what made 3I Atlas so disorienting wasn't its strangeness, but the mirror it held up to our understanding. For centuries we had sorted the cosmos into neat categories: planets and moons, asteroids and comets, stars and nebulae. But here was something that slipped between our definitions, something that reminded us that the universe is not obligated to conform to our taxonomies. It existed whether or not we could properly classify it. The sky defies our categories not out of defiance, but because infinity cannot be contained in finite words. When mathematicians first calculated the trajectory of 3I Atlas, they expected to find the telltale signature of gravity's influence, the hyperbolic path of an object, making a single passage through our solar system before returning to the vast between-star wilderness. What emerged instead from their calculations was something so precise it seemed almost deliberate. The curve of its approach, the angle of its passage relative to the ecliptic plane, the subtle accelerations and decelerations all followed patterns of such elegant complexity that they resembled music more than motion. Some equations are too beautiful to be mere coincidence. As the data accumulated, a strange harmony revealed itself in the numbers. 3I Atlas wasn't simply falling through space as gravity dictated. Its path incorporated subtle deviations that, when mapped across time, created geometric patterns of startling regularity. These weren't the random perturbations caused by outgassing or collision. They were too consistent, too rhythmic, like the steps of a dance choreographed to music we couldn't hear. Astrophysicists began to search for external forces that might explain these movements. Stellar winds, magnetic field interactions, radiation pressure, all were considered and found insufficient. When the cosmos moves with precision, we must question who or what keeps the time. The deeper researchers delved into the orbital mechanics, the more unsettling the precision became. 3E Atlas was moving through our solar system in a way that maximized its proximity to certain celestial bodies while maintaining a perfectly calibrated distance from others. It was as though the object was sightseeing, or perhaps sampling specific regions of our cosmic neighborhood. Statistical analysis confirmed what intuition suggested. The odds against such a path occurring naturally were astronomical. Yet there it was, traced across our sky with mathematical perfection. Probability trembles when faced with patterns that should not exist. Perhaps most intriguing was the relationship between 3I Atlas's trajectory and the historical positions of our planets. Detailed backward projections revealed that its path intersected locations where Neptune, Uranus, and Saturn had been decades or centuries earlier, as if the visitor were following breadcrumbs across the cosmos. This observation led to uncomfortable questions. Was this merely coincidence? Or was 3I Atlas somehow responding to the gravitational memory etched into the fabric of space itself? And if the latter, how could an inert object possess such sensitivity? Some said it was math, others whispered it was memory. The calculations became increasingly complex as astronomers attempted to determine the object's origin. Most interstellar visitors can be traced back to their home systems, their trajectories unwound across time and space to reveal their birthplaces. But 3I Atlas defied these efforts. Its path, when projected backward, seemed to originate from a point between stars, a cosmic no-man's land where no planetary system existed. It was as if it had materialized from the void itself, or perhaps had traveled so long that its origin point no longer existed in any recognizable form. The universe keeps certain addresses hidden, even from those who chart the stars. In quiet conversations after formal meetings had ended, some researchers began to entertain previously unthinkable hypotheses. What if the mathematical precision wasn't a product of natural forces at all? What if it indicated something more unsettling, intention, purpose, design? Such speculation remained largely confined to private discussions, deemed too extraordinary for official reports. Yet the question lingered in the background of every analysis, every calculation. What are the odds that nature alone could create such perfect geometry across the canvas of space? When a pattern appears too perfect, we must ask whose hand might have drawn it. The mystery deepened when orbital specialists noticed subtle accelerations that couldn't be explained by gravity, solar radiation pressure, or outgassing. The object was moving as though responding to forces we couldn't detect, or perhaps couldn't comprehend. This wasn't unprecedented. The famous Oumuamua had displayed similar anomalous acceleration during its 2017 passage. But where Oumuamua's behavior had been relatively straightforward, 3I Atlas's movements incorporated complex variations that suggested either an internal mechanism or an interaction with aspects of space-time we had yet to discover. The pattern of the impossible is often written in the language of the inevitable. Before 3I Atlas came, Oumuamua, that enigmatic messenger from beyond our solar system that briefly captured humanity's imagination in 2017. Cigar-shaped, reddish, tumbling through space like a celestial javelin, it accelerated away from our sun in ways that defied easy explanation, prompting speculation that ranged from the prosaic to the profound. Some suggested outgassing, others proposed a light sail responding to solar radiation. A few brave souls even whispered the word artificial. But whatever it was, Oumuamua slipped away before we could properly introduce ourselves, leaving behind more questions than answers. First encounters rarely reveal their true significance until the second hello. Oumuamua's brief appearance was followed by Borisov, a more conventional interstellar comet that nonetheless reminded us that the space between stars is not as empty as we once imagined. These visitors were thought to be rare cosmic accidents, random travelers on billion-year journeys. Yet here was 3i Atlas, arriving just a few years later, tracing a path that echoed aspects of Oumuamua's journey while introducing new complexities. The statistical improbability of 3 interstellar objects passing through our inner solar system in such quick succession was not lost on the astronomical community. Coincidence is the universe's way of remaining anonymous. What connected these cosmic wayfarers? Was there some unseen current in the interstellar medium, channeling distant matter toward our sun, like celestial driftwood caught in an ocean stream? Or was it possible that these weren't random encounters at all, but data points in a pattern we were only beginning to discern? As astronomers overlaid the trajectories of all 3 objects, subtle alignments emerged, correlations that hovered at the edge of statistical significance. Not quite conclusive, but unsettling in their persistence. History, it seems, doesn't repeat itself in space. It echoes. The similarities between Oumuamua and 3i Atlas extended beyond their anomalous accelerations. Both objects were relatively small, both reflected light in unexpected ways, and both defied easy categorization. But where Oumuamua announced its presence with a distinctive shape and tumbling rotation, 3i Atlas seemed more reticent, more controlled in its passage. If Oumuamua had been a shout across the cosmic void, 3i Atlas was a whisper, more difficult to hear, but perhaps carrying a more nuanced message. Some conversations across the cosmos take decades to complete. As researchers compared data from both objects, a troubling question began to form. What if they were not separate phenomena but connected events? What if, despite the vast differences in their apparent nature, they represented aspects of the same underlying reality? This line of inquiry remained speculative, relegated to late-night discussions and informal exchanges. Yet it persisted, fueled by the nagging sense that we were witnessing not random occurrences, but chapters in a narrative whose full scope exceeded our current understanding. The universe rarely sends just one messenger when the message is important. Most unsettling was the timing. Astronomers had scanned the skies for centuries, developing increasingly sophisticated techniques and technologies, yet only in recent decades had we detected interstellar visitors. Was this simply the result of improved observation capabilities, or was something changing in the cosmic environment around us? Were we witnessing the beginning of a new astronomical phenomenon, or merely becoming aware of a process that had always been occurring? Either possibility carried profound implications for our understanding of the space beyond our solar borders. Perhaps we weren't ready to see what had been passing through all along, high in the mountains of Chile, where the air thins and the stars draw closer. Astronomers at the European Southern Observatory maintained their vigil. Night after night, as the great mirror of the Very Large Telescope gathered ancient light, they tracked 3i Atlas on its silent journey. Similar scenes unfolded at observatories around the world, in Hawaii's volcanic highlands, on Puerto Rico's verdant hills, in the frost-touched domes of the Arctic Circle. Humanity's collective gaze, extended through glass and silicon, reached outward to touch the stranger in our midst. When all eyes look in the same direction, even silence becomes a form of communion. The work was exhausting, demanding. Every photon counted, every moment of clear skies precious. Astronomers spoke of a strange tension in those observation sessions, not the familiar excitement of discovery, but something deeper, more primal. It was as if they were standing at the edge of a vast, dark forest, straining to identify a sound just beyond the range of hearing. The object revealed itself reluctantly, offering glimpses rather than exposures, suggestions rather than statements. And in that reluctance lay its most compelling quality. Even the stars hold their breath when something new wanders among them. Teams worked in shifts, analyzing real-time data, refining models, adjusting parameters. Coffee cups accumulated in trash bins as hours blended into days, days into weeks. Personal lives were postponed, sleep deferred. This wasn't merely professional curiosity. It was something approaching obsession, though few would admit it. There was a sense among the observers that they were witnessing something singular, something that might not pass this way again. Each measurement, each image, each data point felt weighted with significance beyond its scientific value. Even silence has a frequency, and 3i Atlas was humming in the dark. The radio telescopes listened too, their massive dishes turned toward the visitor like colossal ears pressed against the wall of night. The Green Bank Observatory in West Virginia, the Allen Telescope Array in California, the Square Kilometre Array across South Africa and Australia, all tuned to frequencies that might carry a signal, a pattern, a pulse. Nothing came, or rather nothing they could distinguish from the cosmic background radiation that fills our universe like the memory of its birth. Yet the silence itself seemed meaningful, as if the absence of expected noise was itself a message. Sometimes the most profound statement is the word left. Unspoken optical telescopes captured enigmatic images, frames filled mostly with darkness punctuated by a faint, indistinct shape that seemed to change slightly with each exposure. Infrared sensors detected thermal emissions that fluctuated according to patterns that had no obvious correlation with the object's distance from our sun. Spectroscopes recorded absorption lines that appeared and disappeared, as if key elements were phasing in and out of detectability. Each instrument told a different story, yet all shared a common theme: uncertainty, ambiguity. The sense that 3i Atlas was less a physical object than a question embodied. The universe speaks most clearly when it refuses to make sense. In control rooms around the world, the mood oscillated between frustration and wonder. Scientific investigation thrives on clarity, on reproducible results, on phenomena that can be measured and categorized. 3i Atlas offered little of this comfort. Instead, it presented a puzzle whose pieces seemed to change shape each time they were examined. Younger researchers proposed increasingly exotic theories to explain the contradictory data. Their more seasoned colleagues urged caution, patience, restraint, while privately acknowledging that conventional explanations were proving inadequate. Even the data seemed afraid to speak. As information flowed between observatories, processed and shared through secure channels, anomalies began to appear, not just in the observations themselves but in the systems recording them. Equipment that had functioned flawlessly for years developed intermittent glitches when focused on 3i Atlas. Digital storage media containing related data showed higher than normal corruption rates. Computer models crashed when attempting to simulate certain aspects of the object's behavior. Engineers found no hardware faults, no software bugs, no explanation for these technological hiccups. Just another layer of strangeness surrounding an already perplexing phenomenon. Technology falters when it encounters something truly unknown. The computational models that serve as astronomy's crystal balls, allowing scientists to predict the movement and behavior of celestial objects with remarkable accuracy, struggled with 3i Atlas. Initial simulations produced results so divergent from actual observations that researchers assumed input errors. But even after multiple recalibrations, the models consistently failed to predict the object's actual position and characteristics. It was as if 3i Atlas existed slightly out of phase with the mathematical framework we use to describe our universe. Some equations refuse to capture what they describe, like trying to hold moonlight in a jar. As weeks passed, the data accumulated, terabytes of information flowing into specialized databases, analyzed by algorithms designed to find patterns in cosmic noise. These systems, trained on decades of astronomical observations, began to flag anomalies that human researchers had missed. Subtle correlations between the object's rotation rate and its spectral emissions. Microscopic deviations in its trajectory that occurred with mathematical regularity. Relationships between its apparent size and its distance from Earth that defied the inverse square law of optical physics. Even our most sophisticated algorithms whispered, "Something isn't right." The computational abnormalities extended beyond mere prediction failures. When researchers attempted to run Monte Carlo simulations, mathematical models that account for randomness and probability, the results clustered around outcomes that statisticians described as suspiciously ordered. It was as though the random elements of the simulation were being subtly guided toward specific conclusions. Several prominent universities launched independent analyses of the original code, searching for bugs or flaws that might explain these unexpected results. They found none. When numbers dance to music we cannot hear, mathematics itself becomes mysterious. Perhaps most disturbing were the temporal patterns that emerged from long-duration observations. 3i Atlas appeared to interact with light differently, depending on who was watching and when. Observations made during certain phases of Earth's rotation yielded different results than those made at other times. Data collected, when multiple observatories were focused on the object, simultaneously showed greater coherence than isolated observations. It was as if 3i Atlas were responding to the collective attention being paid to it, a notion so unscientific that few researchers would acknowledge it openly. The data that refused to behave had started to behave very specifically. Amidst the technological challenges and data anomalies, a more fundamental question began to take shape. What exactly was 3i Atlas made of? This question, seemingly straightforward, proved remarkably difficult to answer. Spectroscopic analysis, which normally reveals a cosmic object's chemical composition by examining the light it absorbs or reflects, returned contradictory results. At times, the spectrum suggested common materials, silicates, carbon compounds, perhaps traces of water ice or frozen gases. At other times, it hinted at more exotic substances or combinations that had no terrestrial equivalent. The universe occasionally reminds us that our periodic table is merely a local dialect. Comets are cosmic time capsules, preserving the primordial materials from which our solar system formed. They carry the chemical signatures of their birthplaces, the isotopic ratios that tell tales of ancient stellar forges. When we study a comet, we read a story billions of years in the making, a narrative written in ice and dust. But 3i Atlas offered no such chronicle. Its composition, when briefly glimpsed through our instruments, revealed no clear heritage, no chemical autobiography that would allow astronomers to trace its origins. To be without a past is to exist outside the story the universe tells about itself. This absence of history was perhaps the object's most unsettling quality. Every other celestial body we have studied carries markers of its formation, elemental abundances that place it within the context of cosmic evolution. Even Oumuamua, for all its strangeness, displayed spectral characteristics that linked it to known processes of stellar and planetary development. 3i Atlas, by contrast, seemed to exist in a state of chemical anonymity, its composition either concealed from our instruments or genuinely unique in our experience of the cosmos. To be without a past is to be endlessly mysterious. What does it mean for something to come from nowhere? This question haunted the researchers as they grappled with 3i Atlas's apparent lack of origin. Some suggested that perhaps its surface had been altered by billions of years of exposure to cosmic radiation, erasing whatever chemical markers might once have identified its birthplace. Others proposed more exotic explanations, that it had formed in regions of space with different physical laws, or that it represented a class of object we had never before encountered. These hypotheses remained speculative, more thought experiments than formal theories. The stars know where they were born. Only the truly strange forget their origins. As observations continued, astronomers noted another curiosity. 3i Atlas showed none of the expected signs of aging that characterize most interstellar objects. No micrometeorite impact scarred its surface. No radiation darkening altered its reflectivity. It appeared in every measurable way pristine, as if it had been formed yesterday rather than eons ago. This preservation defied explanation, particularly for an object that must have traveled through the harsh environment of interstellar space for an extended period. It was as if 3i Atlas existed outside the normal flow of time and its erosive effects. Time touches all things in the cosmos, except those that exist beyond its reach. The pristine nature of the object raised uncomfortable possibilities. Either 3i Atlas was incredibly young by cosmic standards, having somehow formed in the space between stars, rather than within a planetary system, or it possessed properties that rendered it immune to the processes of cosmic weathering. Both options challenged fundamental assumptions about the nature of matter and the life cycles of celestial bodies. A third possibility, that the object was periodically renewed or maintained, ventured into territory so speculative that few astronomers would discuss it except in the most theoretical terms. Some travelers arrive unchanged because they have never truly departed. As the mystery of Three-Eye Atlas deepened, a term began to circulate among astronomers, first in private communications, then in more formal discussions: black swan. The phrase, borrowed from statistics and epistemology, refers to events so rare and unexpected that they force a re-evaluation of existing knowledge. The 16th century European belief that all swans were white was shattered by the discovery of black swans in Australia, a simple observation that collapsed an entire framework of certainty. Was Three-Eye Atlas our astronomical black swan, the exception that would disprove our rules? The universe doesn't warn before it changes the rules. The black swan hypothesis gained traction as conventional explanations continued to fall short. If Three-Eye Atlas was indeed something fundamentally new, not merely an unusual example of a known phenomenon, but a genuinely novel category of cosmic object, then its implications extended far beyond this single observation. It suggested that our understanding of interstellar space, of the matter that exists between stars, of the very processes that govern the formation and evolution of celestial bodies, might be incomplete in ways we had not previously considered. Sometimes knowledge advances not through discovery, but through bewilderment. Scientific revolutions often begin not with answers, but with anomalies, observations that cannot be reconciled with existing frameworks of understanding. The precession of Mercury's orbit, inexplicable under Newtonian physics, helped lead to Einstein's theory of relativity. The photoelectric effect, which classical electromagnetism couldn't explain, pointed the way toward quantum mechanics. Could Three-Eye Atlas be playing a similar role in the evolution of astronomical knowledge? Could its strangeness be the first indication of a deeper reality we had yet to comprehend? The most important discoveries often announce themselves as errors in our calculations. As the object continued its journey through our solar system, the scientific community found itself divided. Some researchers embraced the black swan interpretation, arguing that Three-Eye Atlas represented a genuine paradigm shift in our understanding of interstellar objects. Others maintained more conservative positions, suggesting that the anomalies would eventually be explained through refinements of existing theories. The debate was not merely academic. It reflected fundamental questions about how science responds to observations that challenge its foundational assumptions. Progress comes when we admit that the map we've drawn no longer matches the territory we observe. The division extended beyond interpretations of the data to questions about how the investigation itself should proceed. Traditional protocols emphasized methodical analysis, peer review, and the gradual accumulation of evidence, processes that unfold over months or years. But Three-Eye Atlas was moving away from us with each passing day, its mysteries receding along with its physical presence. Some argued for more aggressive observation strategies, for the immediate deployment of space-based assets, for approaches that prioritized data collection over procedural caution. The object's transient nature created an urgency that scientific institutions were not designed to accommodate. When the extraordinary passes by, ordinary methods may not be sufficient. In the vast emptiness of space, patterns should not exist. Randomness should reign supreme, with matter and energy distributed according to the cold equations of physics and probability. Yet as astronomers mapped the trajectory of Three-Eye Atlas against the backdrop of stars and planets, unsettling geometries began to emerge. The object's path didn't merely intersect our solar system. It traced a course that corresponded with remarkable precision to certain astronomical alignments, certain mathematical ratios that appeared too ordered to be coincidental. What if randomness is just a pattern too vast for us to see? The first to notice these correlations was a young postdoctoral researcher, working late in the quiet hours when the observatory belonged to the night shift. Plotting Three-Eye Atlas's trajectory against various celestial landmarks, she observed that the object's closest approaches to planets and dwarf planets in our solar system occurred at intervals that followed the Fibonacci sequence, that famous mathematical pattern where each number is the sum of the two preceding ones. The statistical probability of this occurring by chance was vanishingly small, yet there it was, written across the sky in the language of orbital mechanics. Numbers are the universe's native tongue, spoken in whispers we rarely comprehend. As other researchers confirmed these findings, additional patterns revealed themselves. The object's path created precise angles with the ecliptic plane at points that aligned with the golden ratio, that irrational number approximately equal to 1.618 that appears throughout nature in the spirals of galaxies and the arrangement of sunflower seeds. Its velocity changed at moments that corresponded to prime number intervals when measured against certain astronomical baselines. These weren't the chaotic variations expected of a natural object responding to gravitational influences, but the ordered progression of something following an embedded mathematics. Some patterns are so precise they can only be coincidence or conversation. Most intriguing were the alignments with objects beyond our solar system. At specific points in its trajectory, 3i Atlas created straight-line configurations with particular pulses, those rapidly rotating neutron stars that emit regular radio pulses like cosmic lighthouses. These alignments occurred too frequently to be random chance, yet served no apparent navigational or physical purpose. It was as though the object were acknowledging these stellar beacons, or perhaps using them as reference points in some incomprehensible celestial choreography. The stars have always been our guides. Perhaps they guide others too. Pulsars themselves have a storied connection to the search for extraterrestrial intelligence. The famous Pioneer plaques, carried on spacecraft designed to leave our solar system, featured a map using pulsars to pinpoint the location of Earth, a cosmic address written for any intelligence that might find these human-made messengers. That 3i Atlas appeared to reference these same celestial landmarks, struck some researchers as a profound coincidence, while others wondered if it might represent something more significant, a response, perhaps to our own attempts at cosmic communication. Some conversations span centuries, with replies coming long after questions are forgotten. As mathematicians delved deeper into these patterns, they discovered layers of complexity that defied simple explanation. The correlations existed not just in physical space, but in multiple dimensions of analysis: time, frequency, relative motion, spectral characteristics. It was as if 3i Atlas were not just an object moving through space, but a nexus of relationships, a focal point where disparate aspects of cosmic reality converged according to principles we were only beginning to perceive. The mathematics required to describe these relationships stretched the capabilities of existing analytical frameworks. The universe's deepest patterns require mathematics we haven't yet invented. Most scientists approach these findings with appropriate skepticism. The human mind, after all, is predisposed to find patterns even in random noise, a phenomenon known as apophenia that has led to countless misinterpretations throughout the history of science. Were these mathematical correspondences truly present in the data, or were they artifacts of our desire to impose order on the chaotic? Rigorous statistical analyses were conducted, attempting to determine whether the observed patterns exceeded the threshold of coincidence. The results, while not conclusive, leaned disturbing towards significance. We see faces in clouds because we are designed to recognize ourselves. What patterns do we see in stars? Beyond the mathematical alignments lay an even more subtle phenomenon, one so faint, so elusive, that researchers hesitated to include it in formal reports. Sensitive radio telescopes, designed to detect the faintest whispers from the depths of space, had registered something emanating from the direction of 3i Atlas. Not a signal in the conventional sense, not a broadcast or a beacon, but a rhythmic fluctuation in the background radiation, a pulse so regular it resembled a heartbeat, slowed to the tempo of cosmic time. Even the stars have heartbeats. Some just whisper slower than time. The pulse occurred at intervals of approximately 147 seconds, a period that corresponded to no known natural phenomenon associated with objects of 3i Atlas's size or composition. It wasn't the rotation period of the object itself, which had been measured at a different value. It wasn't a harmonic of any obvious physical process. It simply was a rhythmic presence in the data that persisted across multiple observations from different facilities using different equipment. Engineers checked for instrumental artifacts, for interference patterns, for any technical explanation that might account for this regularity. They found none. Between signal and noise lies a twilight realm where meaning itself is uncertain. The pulse wasn't strong enough to represent deliberate communication, at least not in any sense that aligned with human conceptions of messaging. Its energy output was minuscule, barely distinguishable from background radiation. Yet its persistence and regularity suggested something beyond random fluctuation. Some researchers compared it to a lighthouse, not one designed to be seen across vast distances, but rather a navigational aid intended for something already nearby. Others likened it to a beacon that wasn't meant for human detection at all, operating on principles and for purposes beyond our understanding. Some signals aren't meant for us to hear, yet we listen anyway. What troubled astronomers most wasn't the existence of the pulse, but its responsiveness. When multiple radio telescopes observed 3I Atlas simultaneously, the rhythm changed slightly, becoming more regular, more defined, as if strengthening under attention. When observations ceased, later measurements showed the pulse had reverted to its previous fainter state. This apparent reaction to being observed violated basic principles of physics. Inanimate objects don't respond to attention. They don't perform for an audience. They simply exist, indifferent to whether their existence is witnessed. The observer effect is scientific fact. The observed effect remains a mystery. As data continued to accumulate, subtle variations in the pulse revealed themselves, modulations, in amplitude and slight shifts in frequency that created patterns within patterns. These variations didn't correspond to any known natural language or code, yet they displayed a complexity that suggested more than random fluctuation. Statistical analyses indicated a degree of information density comparable to that found in biological systems, not as ordered as human language, but far more structured than random noise. It occupied that tantalizing middle ground where meaning seems just beyond the reach of comprehension. Some symphonies are composed in frequencies we were never meant to hear. The pulse became known among researchers as the heartbeat, a nickname that reflected both its rhythm and the uncomfortable sense that it represented something alive, or at least something that mimicked the characteristics of life. This terminology was discouraged in official communications as being unscientific, anthropomorphic, potentially misleading. Yet it persisted in private conversations, in late-night emails, in the shorthand that develops among colleagues working at the boundaries of understanding. Sometimes metaphor captures truth that technical language cannot reach. The pulse beneath the light spoke in a language older than words. As the scientific investigation of 3I Atlas progressed, a question that had lurked at the margins of discussion began to move toward the center. Could this object be artificial? The possibility had been raised earlier, then dismissed as speculative, unscientific, premature. But as conventional explanations continued to fall short, as the patterns in the object's behavior became increasingly difficult to reconcile with natural phenomena, the hypothesis of artificiality gained reluctant traction even among traditionally conservative researchers. The stars have seen civilizations rise and fall. Perhaps one of them remembers us. The case for artificiality rested on multiple observations: the mathematical precision of 3I Atlas's trajectory, the unusual composition that defied easy categorization, the regular pulse that emanated from it like a beacon, the way it interacted with light and other electromagnetic radiation, its apparent responsiveness to observation. None of these characteristics alone proved non-natural origin, but collectively, they presented a constellation of anomalies that invited speculation about intelligent design. Not proof, certainly, but a hypothesis that could not be casually dismissed. The difference between technology and magic blurs across sufficient distance. Historical context lent weight to these considerations. Throughout the history of astronomy, unexplained phenomena had occasionally been attributed to intelligent action, only to be later explained through natural processes. The canals of Mars, once thought to be evidence of Martian civilization, were optical illusions. The regular pulses from neutron stars were briefly considered potential alien signals before being understood as natural cosmic lighthouses. Caution was warranted. Yet the complex, multidimensional strangeness of 3I Atlas seemed to exceed these historical precedents. Imagination is both a gift and a trap when facing the truly unknown. The artificiality hypothesis fractured along predictable lines. Some researchers envisioned a probe, a device deliberately sent to observe our solar system, perhaps as part of a vast reconnaissance network spanning the galaxy. Others suggested a derelict, the abandoned remnant of some ancient technological civilization, drifting through space long after its creators had vanished. Still others proposed something more abstract, an artifact whose purpose transcended human categories of understanding, operating according to principles beyond our current scientific framework. Some technologies answer questions we haven't yet learned to ask. What unified these varied interpretations was the notion that 3i Atlas represented contact, not direct communication perhaps, but evidence that we were not alone in our capacity to shape matter according to design rather than chance. This possibility carried profound implications not just for astronomy but for humanity's conception of its place in the cosmos. If 3i Atlas was indeed artificial, then the universe contained not just the possibility, but the reality of other minds, other technologies, other ways of engaging with cosmic existence. The question isn't whether we are alone, but whether we would recognize company. Despite the growing case for artificiality, mainstream scientific institutions maintained public skepticism. Official statements emphasized the need for additional data for rigorous analysis, for exhaustive exploration of natural explanations, before considering more exotic hypotheses. This caution was entirely appropriate. Extraordinary claims do require extraordinary evidence. Yet privately, in secure communications and closed-door meetings, the discussion had shifted from whether artificiality was possible to what kind of artifact 3i Atlas might represent. Silence is sometimes the sound of minds changing. As 3i Atlas continued its silent journey through our solar system, astronomers noticed something odd about the space around it. Light from distant stars seemed to bend slightly as it passed near. The object, not the dramatic warping associated with black holes or massive bodies, but a subtle distortion that exceeded what the object's estimated mass could explain. It was as though 3i Atlas existed at the center of a gentle depression in the fabric of space-time, a shallow gravity well that affected passing photons in ways that defied conventional physics. Space itself seemed to hesitate in its presence. This distortion wasn't uniform. It fluctuated in rhythms that corresponded to the mysterious pulse emanating from the object. When the pulse strengthened, the spatial distortion increased. When it weakened, space-time returned closer to its expected configuration. This correlation suggested a relationship between the two phenomena, as if the pulse were not merely a signal, but an effect of whatever mechanism was creating the spatial anomaly. Or perhaps they were different expressions of the same underlying process, a technology or natural phenomenon that manipulated the fundamental properties of reality itself. Some technologies don't simply exist within space-time, but converse with it. The light distortion extended beyond simple gravitational lensing. Spectral analysis of starlight passing near 3i Atlas revealed subtle shifts in wavelength that couldn't be explained by conventional redshift or blue shift. It was as though the light were being processed somehow, its inherent properties altered by passage through the region surrounding the object. This effect was most pronounced in particular frequency ranges, creating patterns that some researchers compared to acoustic resonance or optical filtering. As if 3i Atlas were listening to the universe through specific channels. The light that bent too gently carried secrets we couldn't yet translate. Perhaps most perplexing was the relationship between these spatial anomalies and 3i Atlas's movement through our solar system. The object didn't appear to be propelled in any conventional sense. There were no visible exhaust plumes, no radiation signatures suggesting reaction mass, no evidence of solar sails or magnetic interactions with the solar wind. Yet it moved, with precision, occasionally adjusting its trajectory in ways that maintained its complex relationship with various celestial bodies. It was as though the spatial distortion itself were both medium and mechanism, a manipulation of space-time that allowed for motion without conventional propulsion. To move without moving may be the universe's oldest secret. Engineers and theoretical, Physicists began to develop models attempting to explain these observations. Some proposed exotic matter with negative mass, a hypothetical substance that could potentially create the observed effects. Others suggested interactions with dimensions beyond the familiar 3 of space and 1 of time, higher dimensional. Physics that might manifest in our reality as apparent violations of conservation laws. Still others explored the possibility of vacuum energy manipulation, technologies that could potentially extract power from the quantum foam that permeates empty space. The gap between what we can observe and what we can explain grows wider at the edges of understanding. These theories remained speculative, more thought experiments than formal scientific models. The mathematics required to fully describe the observed phenomena pushed against the boundaries of current physics, suggesting either errors in the observations themselves or the need for new physical frameworks. Several prominent theoretical physicists acknowledged privately that if the data were accurate, they pointed toward principles beyond the standard model, perhaps even beyond current conceptions of how reality itself is structured. When observations challenge theory, reality is teaching us humility. As 3 Atlas continued its journey past the orbit of Mars, then Jupiter, its mysteries only deepened. The spatial distortions became more pronounced, even as the object itself grew fainter, more difficult to observe directly. It was as though its physical presence were diminishing, while its effect on the surrounding cosmos intensified, a paradox that defied easy explanation. Some researchers suggested that what we were observing wasn't a conventional object at all, but the 3-dimensional shadow of something that existed primarily in dimensions we couldn't directly perceive. The light that bent too gently spoke of realities we had yet to comprehend. Days turned to weeks, weeks to months. 3I Atlas continued its silent journey through our solar system, gradually receding from Earth's immediate neighborhood. The intensity of observation diminished, not from lack of interest, but from practical limitations. The object was moving away, becoming fainter, harder to study with each passing day. Data continued to accumulate, but at a slower rate. The window of direct investigation was closing, leaving researchers with the uncomfortable realization that many of their questions might remain permanently unanswered. We watched it fade, but it had already changed the watcher. In those final weeks of optimal observation, a subtle shift occurred in the scientific community's approach to 3I Atlas. The urgency of data collection gave way to deeper reflection on what had already been observed. Researchers who had been working 18-hour days, subsisting on caffeine and determination, found themselves stepping back, contemplating not just the object itself, but what its passage meant for human understanding of the cosmos. The visitor had not merely passed through our solar system, it had passed through our conception of what was possible. Some encounters change us not by what they reveal, but by what they leave uncertain. Time itself seemed to slow during this period, not in any physical sense, but in the psychological experience of those involved in the observation. Days took on a dreamlike quality, with researchers reporting a strange sense of temporal displacement, as if they were operating slightly out of sync with the normal flow of human activity. Some attributed this to simple exhaustion, to the effects of long hours and intense concentration. Others wondered privately if it might be connected to the temporal anomalies associated with 3I Atlas itself, as if proximity to the object, even through observation, somehow affected one's relationship with time. Time, slowed by wonder, becomes a different kind of space. As direct observation became increasingly difficult, astronomers turned their attention to secondary effects, the subtle ways in which 3I Atlas's passage had affected the solar system itself. Dust particles in the object's wake displayed unusual alignment patterns, as if influenced by electromagnetic fields that shouldn't exist. Subtle perturbations appeared in the orbits of small bodies it had passed near, not the expected gravitational effects, but something more complex, more persistent. It was as though the visitor had left fingerprints on the cosmic clockwork, small adjustments that would continue long after it had departed. Some travelers leave footprints in soil, others leave them in time. With each passing day, 3I Atlas moved further from Earth, its signal weakening, its mysteries receding along with its physical presence. The data flow slowed to a trickle, then to isolated droplets of information extracted from increasingly noise-dominated observations. The object that had briefly commanded the attention of the world's most powerful astronomical instruments faded back into the darkness from which it had emerged, leaving behind more questions than answers. Its departure felt not like an ending, but like an incomplete sentence, a thought left deliberately unfinished. The most profound conversations often end in silence. Dr. Elena Kazarian, a senior astronomer at the European Southern Observatory, who had led much of the observational effort, later described a recurring dream that began during the final weeks of the 3I Atlas study. In this dream, she stood on an ancient shoreline watching as something impossible hovered above the distant waves. Not a craft or a creature, but a presence, something that existed at the intersection of matter and concept. In the dream, she understood that it had been there throughout human history, watching, waiting, occasionally allowing itself to be glimpsed. Perhaps the universe only visits those who still remember how to wonder. The dream varied in its details, but maintained its core elements: the ancient sea, the hovering presence, the sense of recognition without understanding. Dr. Kazarian wasn't alone in reporting such experiences. Several researchers involved in the 3I Atlas observation described similar dreams or waking impressions, a feeling that the object had somehow imprinted itself on their consciousness, leaving behind an echo that resonated in the quiet hours. When rational thought gives way to deeper currents of awareness. These accounts were documented not in scientific papers, but in private journals, in conversations among trusted colleagues. Dreams are the mind's way of processing what waking thought cannot contain. Psychological specialists brought in to consult with the research team suggested that these shared experiences represented a natural response to prolonged engagement with profound mystery, the mind's attempt to create narrative coherence around phenomena that defied conventional understanding. This explanation was entirely reasonable, grounded in established principles of cognitive psychology. Yet it didn't quite account for the specificity of the shared elements, for the way these dreams seemed to communicate something essential about 3I Atlas that the data alone had failed to capture. The astronomer's dream was not of stars, but of being seen by them. As 3I Atlas faded from direct observation, attention turned to the vast archive of data it had generated, terabytes of information collected by dozens of observatories over months of intense scrutiny. This digital legacy became the focus of continued research, with sophisticated algorithms sifting through the accumulated observations, searching for patterns too subtle for human perception, for correlations that might have been overlooked in the initial analysis. The visitor was gone, but the record of its passage remained, a cosmic text awaiting proper translation. Even after the last note fades, music lingers in the silence that follows. The reanalysis of existing data revealed new layers of complexity. Images from space telescopes, when processed through specialized filters designed to highlight subtle variations in light intensity, showed something remarkable: a faint halo surrounding 3I Atlas, visible only at certain wavelengths and from certain angles of observation. This aura wasn't uniform but structured, with intricate patterns that resembled fractal geometry, or perhaps mathematical notation in an unknown system. It was as though the object were surrounded by information written in light too subtle for conventional detection. Sometimes, what we can't see teaches us more than what we can. The halo appeared most prominently in images captured during specific phases of Earth's rotation and at particular points in 3I Atlas's trajectory, moments when certain astronomical alignments occurred. This correlation suggested that the phenomenon wasn't a continuous feature of the object, but something that manifested under specific conditions, perhaps in response to particular configurations of celestial bodies. It was as though 3I Atlas were engaged in a complex conversation with the cosmic environment, expressing itself not through sound or conventional signals, but through subtle modulations in its interaction with light. Light carries more than illumination. It carries possibility. Most intriguing was the way the halo responded to observation itself. When multiple telescopes focused on 3I Atlas simultaneously, the patterns in the aura became more defined, more complex, as if the act of being observed intensified whatever process was generating this phenomenon. This apparent reactivity challenged fundamental assumptions about the nature of physical reality. Inanimate objects don't respond to attention. They don't adapt their behavior based on whether they're being watched. Yet 3I Atlas seemed to do exactly that, raising profound questions about consciousness, perception, and the relationship between observer and observed. The cold light of stars warms when we remember they are suns. As researchers delved deeper into these observations, they found themselves wandering into philosophical territory rarely explored in mainstream astronomy. What exactly constitutes consciousness? Could an object, whether natural or artificial, possess awareness that differs so fundamentally from human experience that we struggle to recognize it as such? Might there be modes of existence that operate on timescales or through mechanisms so alien to our understanding that they appear as inert matter when viewed through the limited lens of human perception? Reflections in the cold light reveal more about the watcher than the watched. These questions extended beyond scientific inquiry into the realm of ontology, the branch of metaphysics concerned with the nature of being itself. Several prominent philosophers of science joined the ongoing analysis, bringing perspectives that complemented the data-driven approach of the astronomers. They suggested that 3I Atlas might represent not just a physical anomaly, but a conceptual one, a phenomenon that existed at the boundaries of what our current frameworks of understanding could accommodate. Perhaps it wasn't just our instruments that were struggling to measure the visitor, but our very categories of thought that were proving inadequate. Some visitors come not to be understood, but to expand our capacity for understanding. In the months following 3I Atlas's departure from the inner solar system, a quiet debate unfolded within the scientific community. What did this visitor represent? In the larger context of human knowledge, was it merely an unusual natural phenomenon, exotic but ultimately explainable through extensions of existing physics? Was it evidence of technologies beyond our current capabilities, suggesting intelligence elsewhere in the cosmos? Or did it point towards something more profound, a reality more complex, more mysterious than our current science had prepared us to comprehend? The universe as a mirror reflects not stars, but questions. Some scientists embrace this uncertainty, finding in it a humbling reminder of how much remained unknown despite centuries of astronomical progress. Others found it deeply unsettling, a challenge to the foundational assumption that the cosmos is ultimately comprehensible through rational inquiry. Still others adopted a position of pragmatic agnosticism, suggesting that we simply lacked sufficient data to draw meaningful conclusions about 3I Atlas's nature or origins. What unified these varied responses was recognition that something profound had passed through our cosmic neighborhood, something that defied easy categorization or explanation. Scientists debated meaning, philosophers debated significance. What if 3I Atlas wasn't here to reveal itself, but to reflect us? Perhaps most striking was how the visitor had acted as a mirror, revealing not just aspects of the cosmos, but elements of human psychology and social organization. The way different research groups had interpreted the same data through the lens of their existing beliefs. The institutional caution that had sometimes slowed investigation of the most anomalous findings. The tension between rigorous methodology and imaginative speculation that runs through all scientific endeavor. 3I Atlas had become a Rorschach test of sorts, with each observer finding in its ambiguous form reflections of their own preconceptions and anxieties. Maybe we are the experiment, not the observers. This mirroring extended beyond the scientific community to broader human culture. News of the anomalous visitor had reached the general public in fragmented, often sensationalized form. Some saw in 3I Atlas confirmation of long-held beliefs about extraterrestrial presence. Others incorporated it into religious or spiritual frameworks, interpreting it as a sign or portent. Still others dismissed the entire phenomenon as overblown, preferring the comfort of the familiar to the challenge of the truly unknown. The visitor had passed through human consciousness just as it had passed through the solar system, leaving different impressions on different minds. The stories we tell about the stars reveal the constellations in our thinking. As time passed and direct observation became impossible, the initial excitement surrounding 3I Atlas gradually faded from public awareness. Other news took center stage. Other discoveries captured collective attention. The visitor receded not just in physical space, but in the space of human concern, becoming a footnote, a reference point, an episode, rather than an ongoing reality. Yet for those who had been most deeply involved in its study, something had changed permanently. A shift in perspective that couldn't be reversed, a question that couldn't be unasked. The weight of uncertainty is lighter than the weight of false certainty. In observatories around the world, the equipment that had been trained on 3I Atlas was gradually redirected toward other targets, the routine work of astronomy resuming its familiar rhythms. Research papers were published, summarizing what had been observed, acknowledging what remained unexplained. Conferences were held, theories proposed and debated, careers advanced or altered based on contributions to the investigation. The machinery of science absorbed the anomaly, processed it, incorporated it into the ever-growing body of knowledge about our cosmic environment. Certainty is a comfort the stars never promised. Yet beneath this return to normalcy, a current of unease persisted, a subtle but pervasive sense that something fundamental had shifted. Long-established theories had been challenged not by contradictory evidence, but by phenomena that existed outside the framework those theories had been designed to explain. The visitor hadn't broken the rules so much as suggested that the rulebook itself might be incomplete, might be a local ordinance rather than a universal law. This realization cast a long shadow, quiet but persistent, across fields extending far beyond astronomy itself. Some questions once asked continue asking themselves. In the quiet hours when the day's work was done, when the instruments hummed on automatic and the screens displayed familiar patterns, researchers sometimes found themselves returning to the 3I Atlas data, not as part of formal studies but out of a more personal curiosity, a need to reconnect with the mystery that had briefly opened before them. They would scroll through the archived images, review the anomalous readings, trace once more the elegant trajectory that had brought the visitor through our cosmic neighborhood. Not searching for anything specific, perhaps, but for the feeling that had accompanied those observations, the sense of standing at the edge of a larger reality. The data still whispered of something unaccounted for. These informal reviews occasionally yielded new insights, patterns previously overlooked, correlations that became apparent only with the perspective of time and distance. Several researchers noted independently that certain anomalies in the data seemed to intensify when reviewed, as if the record itself possessed some quality that became more pronounced with repeated observation. This suggestion was met with understandable skepticism. Data doesn't change simply because it's examined, yet the consistency of these reports from multiple reliable sources raised questions that couldn't be casually dismissed. Some echoes grow stronger with repetition rather than fading. The most unsettling aspect of these ongoing investigations wasn't what they revealed about 3I Atlas itself, but what they suggested about the nature of observation, about the relationship between consciousness and reality. If the data did, indeed, respond to attention in some subtle but measurable way, what did that imply about the fundamental structures of existence? Was there some level at which mind and matter were not separate domains, but aspects of a unified field, influencing each other in ways our current science could barely begin to comprehend? These questions extended far beyond astronomy, into the deepest waters of quantum physics and the philosophy of consciousness. The observer and the observed dance in patterns older than stars. Researchers found themselves revisiting the infamous measurement problem from quantum mechanics. That strange realm where particles seem to exist in multiple states until observed. For decades, this had been considered a peculiarity of the subatomic world, not something that manifested in macroscopic objects crossing interstellar space. Yet the 3I Atlas data suggested otherwise. When certain researchers focused their attention, So on specific aspects of the archived observations, subtle patterns emerged that hadn't been visible before. When they looked away, turning to other matters, those same patterns became statistically insignificant. It was as though the act of conscious attention itself was a variable in the equation, not just a passive receiver of information, but an active participant in its manifestation. Some realities only exist when we dare to look for them. The implications trembled at the edge of scientific respectability. Veteran physicists who had spent decades building reputations on methodical, materialist approaches to cosmology found themselves drawn into conversations that would once have seemed mystical, even New Age. They spoke in careful, precise language, guarding against sensationalism. But the essence of their discussions increasingly centered on consciousness as a fundamental property of the universe, not an emergent phenomenon arising solely from neural complexity, but perhaps something woven into the fabric of existence itself, something that 3i Atlas had somehow engaged with directly. When the cosmos whispers to your mind, is it truly separate from you? Late-night discussions in observatory break rooms turned philosophical. If consciousness could influence the manifestation of data about an object billions of miles away, what were the boundaries of self? Where did the observer end and the observed begin? These weren't merely abstract speculations. They had practical implications for how the research proceeded. Teams began documenting their mental states during analysis, noting times of focused attention versus distraction. Some even experimented with meditative practices before reviewing particularly anomalous datasets, finding that states of heightened, clear awareness seemed to strengthen the statistical significance of certain patterns. The line between science and contemplation blurs when the universe demands both. Several research groups independently converged on a startling hypothesis. Perhaps 3i Atlas wasn't just being passively observed, perhaps it was, in some sense difficult to articulate, observing us in return, not through conventional sensory apparatus, but through some mechanism that operated at the interface between consciousness and physical reality. The idea wasn't that the visitor contained an intelligence similar to human consciousness, peering through telescope-like devices. Rather, that it existed in a state where the distinction between perceiving and being perceived had collapsed, where observation was inherently bidirectional, a conversation rather than a one-way transmission. What if the sky has always been watching us back? This perspective aligned with certain interpretations of quantum mechanics that had long remained at the margins of mainstream physics, views that placed consciousness not as a late-emerging property of complex neurological systems, but as something foundational to reality itself. Theoretical physicists who had previously explored these ideas cautiously, often facing skepticism from colleagues, found themselves suddenly in demand, invited to share insights previously considered too speculative for serious consideration. Their mathematical models, which incorporated consciousness as a variable in the equations describing reality, began to attract attention beyond their usual small circles. Sometimes understanding requires us to become what we seek to understand. Dr. Eleanor Chen, a physicist who had spent decades exploring the boundaries between quantum mechanics and consciousness, emerged as a central figure in these discussions. Her earlier work, once dismissed as philosophical rather than scientific, now seemed prophetic. She had developed mathematical frameworks suggesting that at certain scales and under certain conditions, consciousness could interact directly with quantum fields, creating effects that would manifest even at macroscopic levels. The 3i Atlas observations provided the first compelling evidence that her models might describe actual phenomena, not merely theoretical possibilities. The equations had been waiting for us, patient as starlight. We have always assumed, Dr. Chen wrote in a widely circulated paper, that the arrow of observation points in one direction, from conscious observer to passive object. But what if consciousness itself is a field that permeates the universe, and what we call observation is simply a local interaction within that field? What if 3i Atlas exists in a state where the barriers we perceive between mind and matter are more permeable, more transparent? Not because it possesses a brain or anything we would recognize as cognitive architecture, but because it embodies a different relationship with the fundamental substrate of reality. Some visitors bring not messages but mirrors that reflect what we've forgotten about ourselves. These ideas spread beyond specialist circles, entering broader scientific discourse. They were met with reactions ranging from excited recognition to dismissive skepticism. Critics pointed out the dangers of projecting human concepts onto non-human phenomena, of mistaking measurement anomalies for metaphysical revelations. But even the skeptics couldn't entirely dismiss the data, which continued to display patterns that defied conventional explanation. Something was happening at the intersection of consciousness and cosmos, something that our existing scientific frameworks struggled to accommodate. When facts and frameworks collide, reality itself asks us to grow. Perhaps most compelling were the consistent reports from multiple independent laboratories that the 3I Atlas data responded differently to different observers. The same dataset, analyzed by different researchers using identical methods and equipment, yielded subtly different results. These variations couldn't be explained by random error or methodological inconsistencies. They correlated specifically with the observers themselves, with their backgrounds, their expectations, their emotional states during analysis. It was as though the data contained a spectrum of potential manifestations, with particular observers drawing forth specific aspects of that spectrum. The stars may speak a universal language, but they whisper a different secret to each listener. A team at the Princeton Engineering Anomalies Research Laboratory, which had previously studied consciousness-matter interactions, designed protocols to systematically explore these effects. They recruited observers with varying backgrounds: physicists, artists, meditation practitioners, individuals with no scientific training, and tracked how the 3I Atlas data responded to each. The patterns were subtle but consistent. Technically minded observers tended to elicit more structured, mathematically regular patterns, while those with artistic or contemplative backgrounds drew forth more fluid, organic manifestations. Yet all were analyzing the exact same datasets. Each mind that touches the mystery reshapes it, however slightly. This led to a profound methodological challenge. If observation itself influenced what was being observed, how could researchers establish objective facts about 3I Atlas? The traditional scientific approach, which assumes an observer-independent reality that can be progressively mapped through careful measurement, seemed inadequate to the task. Some suggested a radical solution, that understanding 3I Atlas required not just collecting more data, but developing new modes of consciousness, new ways of engaging with reality that transcended the subject-object divide inherent in conventional scientific methodology. Perhaps we need to become what we seek to understand. Anthropologists and historians of science noted parallels with indigenous knowledge systems that had never fully embraced the Western separation of consciousness from the material world. For many traditional cultures, the idea that mind and matter exist in continuous dialogue, shaping each other through their interaction, wasn't a radical proposition, but a basic assumption about how reality functions. Several indigenous astronomers were invited to participate in the research, bringing perspectives informed by knowledge traditions that had developed along different lines than Western science. Ancient wisdom sometimes prepares the ground for future understanding. Dr. Maria Running Cloud, an astrophysicist of Lakota heritage, observed that the difficult relationship between consciousness and 3I Atlas echoed traditional indigenous understandings of certain sacred sites and celestial phenomena. "In my culture," she explained, "we have always recognized that how you approach something, the consciousness you bring to an encounter, shapes what is revealed to you. This isn't mysticism. It's a practical understanding of how reality works at certain levels. Western science is only now developing mathematical language for what some traditional knowledge systems have recognized for thousands of years. Some truths have been waiting in plain sight, patient as mountains. As these philosophical inquiries unfolded, more practical considerations emerged from other quarters of the scientific community. If 3I Atlas represented a genuinely new category of cosmic phenomenon, whether natural or artificial, then it was unlikely to be unique. Other similar objects might be passing through our solar system undetected, or might arrive in the future. The visitor had revealed gaps not just in our understanding, but in our observational capabilities. limitations in how we monitor the space around us, in how we distinguish the anomalous from the merely unusual. The cosmos doesn't repeat. It circles patiently. Astronomers realized with humbling clarity how easily 3I Atlas might have passed unnoticed. Its detection had been in many ways a matter of chance. The right telescope pointed at the right patch of sky at the right moment. Our monitoring of near-Earth space, while sophisticated by human standards, covered only a fraction of the vast sphere surrounding our planet. How many other visitors might have passed by unobserved? How many might be moving through our solar system even now, invisible not because they seek to hide, but because we lack the eyes to see them? The darkness between stars holds more than our instruments can capture. This recognition prompted a comprehensive review of existing space surveillance systems. The infrastructure developed primarily to track satellites, space debris, and potentially hazardous asteroids had been designed with specific parameters in mind, objects of particular sizes, moving at particular velocities, reflecting light in predictable ways. But 3I Atlas had demonstrated that the truly extraordinary might not conform to these expectations. It might move differently, interact with light differently, exist in ways that our detection systems simply weren't calibrated to notice. We built our instruments to find what we expected, not what might truly arrive. The review revealed concerning gaps in coverage. Certain approaches to our solar system remained relatively unwatched. Certain velocity profiles unlikely to trigger automated alerts. Certain types of objects almost invisible to existing detection methods. It was as though humanity had installed a sophisticated alarm system that would respond immediately to someone trying to break down the front door, while leaving windows and side entrances minimally protected. And 3I Atlas had slipped through one of those unguarded approaches. Visible only because a routine sky survey had happened to catch a glimpse of its passage. Our cosmic home has many doors we've forgotten to watch. More troubling was the realization that current systems weren't designed to detect objects with the particular anomalous characteristics of Atlas. Its inconsistent interaction with light, its strange thermal profile, its ability to seemingly shift between different observational states. These qualities would cause most automated systems to classify it as instrumental error or noise rather than a genuine celestial body. How many similar anomalies had been filtered out of datasets as probable glitches, discarded before human eyes ever had the chance to recognize their significance? Sometimes the most important signals are the ones our filters are designed to ignore. This realization prompted calls for new observation protocols, for dedicated systems designed specifically to detect and track interstellar visitors. Several major observatories adjusted their search parameters, programming their automated systems to flag objects with characteristics similar to 3I Atlas. Space agencies began developing proposals for specialized satellites that could respond quickly to future anomalies, perhaps even intercepting them for closer study. The visitor had changed not just how we think about the cosmos, but how we watch it, a subtle but significant shift in our relationship with the space beyond Earth. The return of the unknown is not a matter of if, but when. The Vera C. Rubin Observatory, under construction in Chile with its massive 8.4-meter primary mirror and 3,200 megapixel camera, incorporated new detection algorithms specifically designed to identify 3I Atlas-like anomalies. When operational, it would survey the entire visible sky every few nights, generating up to 20 terabytes of data per day, a comprehensive cosmic monitoring system that might catch even the most elusive visitors. Similar modifications were implemented at other major observatories around the world, creating a global network of sensors attuned to the strange and unexpected. The night has a new audience now, more wakeful and wondering. Satellite-based observation systems received similar upgrades. The European Space Agency's Gaia spacecraft, already mapping billions of stars with unprecedented precision, adjusted its anomaly detection parameters. NASA's James Webb Space Telescope incorporated new observational modes designed to rapidly respond to potential interstellar objects with unusual characteristics. Even military space surveillance networks, typically focused on artificial satellites and potential threats to orbital infrastructure, began incorporating detection protocols for objects with 3-eye atlas-like signatures, we have raised our gaze to the stars with new questions in our eyes. These technical adjustments reflected a deeper shift in astronomical thinking, a new awareness that the space between stars might contain phenomena that defied easy categorization. The traditional taxonomy of celestial objects, planets and moons, asteroids and comets, stars and nebulae, had served well for centuries, but 3-eye atlas suggested that reality might be richer, more complex, more varied than these categories could accommodate. Perhaps the cosmos contained classes of objects for which we had no name, no concept, no framework of understanding, and perhaps the most important discoveries wouldn't fit neatly into existing boxes. Categories comfort the mind, but the universe has no obligation to conform to our filing systems. This possibility, that we might be surrounded by phenomena we couldn't recognize because they didn't match our preconceptions, led to the development of what researchers called assumption-neutral detection systems. Rather than looking specifically for known types of objects with expected characteristics, these systems were designed to flag anything that deviated from background patterns, anything that represented a statistical anomaly against the backdrop of normal space. The approach was computationally intensive and generated numerous false positives, but it offered the possibility of detecting truly novel phenomena that conventional systems might miss. Sometimes to see what has always been there, we must first forget what we think we know. Funding for these initiatives flowed not just from traditional scientific sources, but from military and intelligence agencies as well. The strategic implications of potentially overlooking objects like 3-eye atlas, especially if they represented artificial technologies rather than natural phenomena, were not lost on national security establishments. While these agencies approached the matter from a perspective of potential threat assessment rather than scientific curiosity, their resources significantly accelerated the development and deployment of new detection capabilities. Curiosity and caution make for wary partners in the cosmic night. Most ambitious were the proposals for direct exploration, concepts for spacecraft that could potentially intercept future interstellar visitors, studying them up close rather than from astronomical distances. Such missions presented enormous technical challenges. The velocities involved were extreme, the detection times potentially very short, the distances vast. Yet the technologies required were not beyond reach, just at the outer edges of current capabilities, requiring refinement and focus rather than fundamental breakthroughs. Several aerospace engineers began preliminary designs, creating blueprints for vessels that might one day chase the next visitor through the dark. We prepare not just equipment, but imagination for what comes next. The Interstellar Interceptor Concept Study, a joint initiative involving NASA, ESA, and several private aerospace companies, proposed a spacecraft system perpetually stationed at Earth-Sun Lagrange points, gravitational sweet spots where objects can maintain position with minimal fuel expenditure. These vehicles would remain in a state of readiness, fully fueled and equipped with advanced instrumentation. Upon detection of an interstellar visitor, they could rapidly deploy, using high-efficiency propulsion systems to match course and velocity for close observation. The goal wasn't just to see such objects from afar, but to fly alongside them, perhaps even making direct contact. Humanity dreams of conversations that might span the void. The propulsion systems required for such missions pushed against the limits of current technology. Chemical rockets, the workhorses of space exploration since its inception, lacked the necessary combination of thrust and efficiency. More exotic systems were required: nuclear thermal propulsion, fusion drives, electromagnetic sails that could harness the solar wind, or even advanced forms of the ion thrusters, already used in some deep space missions. Engineers found themselves sketching designs that had previously existed, primarily in the realm of theoretical papers and science fiction. The dreams of yesterday become the blueprints of tomorrow. Equally challenging were the detection and tracking systems required to guide such interceptors to their targets. An interstellar object might be identified only days or weeks before its closest approach to our solar system, leaving precious little time for course calculations and mission planning. The interceptors would need to operate with unprecedented autonomy, making complex navigational decisions without waiting for instructions from Earth. This necessitated artificial intelligence systems far more sophisticated than those currently guiding space missions, AI capable of real-time problem-solving in unique circumstances never anticipated by human programmers. Some journeys must be guided by minds we create rather than those we possess. The instrumentation for these hypothetical missions represented another frontier of technological development. How do you study an object that defies conventional categories, that might interact with reality in ways your equipment wasn't designed to measure? Engineers proposed modular sensing packages, incorporating everything from traditional optical and infrared cameras to more exotic instruments, quantum interference detectors, consciousness matter interaction sensors based on Dr. Chen's theoretical work, even devices designed to detect spatial distortions of the kind observed around 3i Atlas. The tools we build reveal the questions we've learned to ask. Perhaps most ambitious were proposals for physical sampling spacecraft, designed not merely to observe interstellar visitors, but to collect material from them for detailed analysis. Such missions would require not just interception, but precise maneuvering alongside objects, potentially moving at tens of kilometers per second relative to Earth. The sampling mechanisms themselves presented numerous engineering challenges, especially given the unknown physical properties of the targets. Would they be solid like asteroids, loose agglomerations of material like cometary nuclei, or something entirely different, with physical characteristics beyond our current understanding? To touch a traveler from beyond our shores might be to grasp the universe's oldest stories. Some engineers proposed more radical approaches. Rather than trying to intercept objects after detection, why not position sampling devices throughout the solar system, creating a three-dimensional net that would passively collect material from anything passing through? Such a network would require hundreds or even thousands of small spacecraft distributed across enormous volumes of space. A challenging proposition with current launch capabilities, but one that might become feasible with the development of in-space manufacturing, using resources harvested from asteroids and other celestial bodies. Patient fishers of the cosmic sea might catch what hurried hunters miss. These practical responses reflected a deeper shift in perspective, a growing recognition that Earth exists within a cosmic context that includes not just the familiar planets of our solar system, but the entire galaxy and the objects that move through it. We had known this intellectually for centuries, of course, but 3i Atlas had made it experiential, had transformed abstract knowledge into lived reality. The boundary of human concern had expanded, encompassing not just the neighborhood of our sun, but the vast spaces between stars and whatever might traverse them. Space agencies began preparing for the next interstellar visitor. But deep down a thought lingered. What if the next one isn't passing by? What if it's coming back? This question, whether future visitors might represent not random cosmic encounters, but deliberate returns, emerged from careful analysis of 3i Atlas's trajectory. There had been something unusually precise about its path through our solar system, something that hinted at calculation rather than coincidence. If it was indeed following a predetermined course, might that course eventually bring it back to our vicinity? And if so, what might that imply about its nature and purpose? Was it merely taking measurements, gathering data for some incomprehensible project? Or was its first passage a reconnaissance, a preparation for something more significant to come? Some passages write the prologue to stories yet untold. Astronomers calculated potential return trajectories based on 3i Atlas's departure vector, accounting for the gravitational influence of stars it might pass near. While the uncertainties were enormous, interstellar, space contains countless unseen influences that might alter its course over vast distances. Certain scenarios emerged in which the visitor might return to our solar system within human timescales. Not soon, decades at minimum, more likely centuries, but potentially within the lifespan of institutions, if not individuals. This possibility, however remote, added urgency to preparations for future encounters. Time moves differently for stars than for those who study them. The notion of intentional return raised uncomfortable questions about the nature of 3i Atlas. Natural objects don't make return journeys across interstellar distances. They might be captured into orbit around stars they encounter, or their paths might be altered by gravitational influences, but they don't deliberately circle back to previous locations. If 3i Atlas were to return, it would strengthen the case for artificial origin, for purpose and design rather than random cosmic wandering. And that, in turn, would force humanity to confront the reality of non-human intelligence in a way no theoretical speculation ever could. The stars have witnessed many civilizations. We may not be the only ones still watching. This possibility, remote yet not dismissible, influenced the development of long-term monitoring strategies. Beyond the immediate improvements to detection systems, researchers began designing observational protocols intended to maintain vigilance over decades and centuries. This required thinking about scientific institutions in timeframes rarely considered, how to ensure that knowledge, expertise, and focus would persist across multiple human generations. How to prevent 3i Atlas and its implications from fading from institutional memory, becoming a footnote rather than a continuing focus of attention. Some watches must be kept by those not yet born. Several major observatories established what they called centennial commitments, formal, institutional pledges to maintain specific monitoring programs for at least 100 years, regardless of changing scientific fashions or funding priorities. Universities created endowed positions for researchers dedicated to the long-term study of interstellar objects. Data preservation systems were designed with century-long timeframes in mind, ensuring that future generations of scientists would have access not just to the conclusions of current research, but to the raw data itself, available for reanalysis, with whatever new tools and perspectives might emerge. Patience becomes its own form of courage when the stars are your clock. These institutional commitments represented a profound challenge to the typically short-term thinking of human organizations. Scientific priorities shift, funding fluctuates, technologies evolve, rendering previous approaches obsolete. Maintaining focus on a specific phenomenon across decades requires a kind of organizational discipline rarely seen outside religious institutions or certain governmental functions. Yet the potential significance of 3i Atlas and what it represented seemed to justify this unusual approach, this attempt to establish scientific continuity across timescales that exceed individual human lifespans. Some questions take generations to answer, but only moments to forget. This expansion of perspective carried with it both exhilaration and unease. The universe had grown larger in human awareness, more complex, more mysterious, a place where the known and the unknown intermingled in ways both beautiful and unsettling. Some found in this a source of wonder, a reminder that discovery remains possible, even in an age when so much has already been mapped and measured. Others felt a more primal response, the ancient wariness that stirs when we sense we are not alone, when we realize we are being watched from the shadows at the edge of the Firelight, wonder and fear are twin children, of the same parent, mystery. The exhilaration manifested in a surge of interest in astronomy and space sciences, particularly among younger generations. University programs reported increased enrollment. Amateur astronomy societies gained new members. Public lectures on cosmic phenomena drew standing-room-only crowds. There was a hunger for understanding, a collective fascination with the possibility that the universe might contain wonders beyond our current comprehension. Books about interstellar objects became bestsellers. Documentaries exploring the implications of 3i Atlas broke viewership records. The public imagination had been captured by this visitor from beyond our solar shores. Curiosity burns brightest when ignited by the truly unknown, yet alongside this excitement ran currents of anxiety. If 3i Atlas represented an artificial construction, a technology created by non-human intelligence, what did that imply about humanity's place in the cosmic hierarchy? We had grown accustomed to thinking of ourselves as the pinnacle of cognitive evolution, at least in our local neighborhood of space. The possibility that we might be neither unique nor particularly advanced in our technological development challenged deep-seated assumptions about human exceptionality about our special role in the cosmic drama. The stars have witnessed many dreams of primacy, yet remain unchanged by any. Religious and philosophical communities engage deeply with these questions. Some theological traditions found in 3i Atlas confirmation of long-held beliefs about the plurality of created beings. Others struggled to reconcile its implications with doctrines that placed humanity at the center of divine concern. Philosophers explored the ethical dimensions of potential contact with non-human intelligence, questioning whether our moral frameworks evolved to govern relations among members of a single species on a single planet could meaningfully extend to truly alien minds with potentially different cognitive architectures and value systems. Faith and reason walk hand in hand when facing questions older than either. These contradictory responses reflected a fundamental tension in the human relationship with the cosmos, a tension between our hunger to know and our fear of what we might discover. Throughout history, astronomical revelations have both expanded and challenged our conception of ourselves. Copernicus showed we were not at the center of creation. Hubble revealed our galaxy to be one among billions. Each discovery diminished our physical centrality, while expanding the context in which we understand our existence. 3i Atlas continued this tradition, suggesting that we might be neither alone nor particularly exceptional in our capacity to shape matter and move through space with purpose. The cosmos doesn't ask to be believed, only noticed. Cultural responses to 3i Atlas varied widely across different societies and demographic groups. Surveys conducted in the years following its passage revealed interesting patterns. Younger respondents generally expressed more excitement than anxiety about its implications, while older demographics tended toward the reverse. People with backgrounds in science, engineering, and other technical fields showed greater comfort with the possibility of non-human intelligence than those from other professional backgrounds. National and regional differences emerged as well, reflecting varying cultural attitudes toward the unknown and the cosmic. Each mind builds its own universe from the same stars. Perhaps most revealing were the differences in response between those who had followed the 3i Atlas research closely and those whose knowledge came primarily through popular media. The former group, regardless of their professional background, tended to express more nuanced views, neither uncritical acceptance of the most exotic interpretations nor dismissal of the genuine anomalies the visitor had presented. They understood both the significance of what had been observed and the limitations of current knowledge, the tension between extraordinary possibilities and the need for extraordinary evidence. Wisdom lies not in certainty, but in the balance between wonder and doubt. Media representation of 3i Atlas varied greatly in accuracy and tone. Some outlets provided thoughtful, measured coverage, exploring the scientific questions without sensationalism, while acknowledging the profound implications of certain possibilities. Others amplified the most extreme interpretations, presenting speculation as fact and ignoring the careful qualifications with which researchers framed their findings. Social media platforms became battlegrounds between competing narratives, with hashtags like #CosmicVisitor and space myths trending as different communities advanced their preferred interpretations. Stories travel faster than light across the digital sky, not all of them true. In the quiet halls of observatories and research institutions, discussions about 3i Atlas gradually evolved from technical analysis to deeper contemplation of its significance. Was this truly a turning point in human understanding of the cosmos? Would future historians mark the visitor's passage as a moment when something fundamental shifted in our relationship with the universe? Or would it prove to be a footnote, an interesting anomaly that yielded no lasting transformation in knowledge or perspective? Only time would provide definitive answers to these questions, but the sense of standing at a threshold persisted among those who had engaged most deeply with the phenomenon. Between logic and faith lies the territory where true discovery happens. Dr. James Whitman, who had coordinated much of the early observational effort from the Mauna Kea observatories in Hawaii, reflected on this sense of threshold in his memoir, Watching the Dark. "There are moments in science," he wrote, "when you feel the ground shift beneath your intellectual feet, when you recognize that the framework you've been using to understand reality may be incomplete in fundamental ways. The passage of Three-Eye Atlas was such a moment for many of us. Even now, years later, I find myself returning to those observations. Those anomalies with the persistent sense that they contain insights we haven't yet fully grasped. Keys, two doors we're still learning how to open. Some mysteries arrive not to be solved, but to remind us how to question. This sentiment that Three-Eye Atlas represented not merely a novel observation, but a challenge to existing frameworks of understanding was echoed by researchers across multiple disciplines. It wasn't just astronomers who felt the ground shifting, but physicists confronting the visitor's strange interaction with spacetime, computer scientists grappling with data that seemed to respond to conscious attention, philosophers exploring the implications for our understanding of mind and matter. Each field found in Three-Eye Atlas anomalies that challenged their foundational assumptions, questions that couldn't be comfortably contained within existing theoretical boundaries. The deepest discoveries don't answer old questions, they ask new ones. For some researchers, the most profound aspect of the Three-Eye Atlas experience wasn't the data collected or the theories proposed, but the ways in which it had challenged the boundaries between scientific disciplines. Astronomers had found themselves exploring questions traditionally reserved for philosophers. Physicists had ventured into territory usually occupied by metaphysicians. Engineers had contemplated concepts that verged on the mystical. These border crossings had been uncomfortable at times, challenging professional identities and methodological commitments. Yet they had also proven extraordinarily productive, yielding insights that might never have emerged within the confines of specialized fields. Science and wonder, two languages, describing the same silence. The interdisciplinary nature of the Three-Eye Atlas research had forced a reckoning with the increasing specialization of modern science. For centuries, scientific progress had been driven by ever finer subdivisions of knowledge, researchers focusing on increasingly narrow domains, developing specialized languages and methodologies suited to their particular corner of inquiry. This approach had yielded remarkable advances, but at the cost of fragmenting understanding. The visitor had demonstrated the limitations of this fragmentation, presenting phenomena that could only be comprehended through the integration of multiple perspectives, through conversation across disciplinary boundaries. Some truths can only be glimpsed in the spaces between established fields of vision. New institutional structures emerged to facilitate these cross-disciplinary conversations. Universities established centers for interstellar studies that deliberately brought together researchers from diverse backgrounds, not just from different scientific disciplines, but from the humanities and arts as well, recognizing that understanding phenomena at the boundaries of comprehension requires multiple modes of inquiry. Funding agencies created grant programs specifically designed to support research that crossed traditional boundaries, that integrated methodologies and perspectives from fields typically separate from one another. The walls between our ways of knowing grow thin when facing what transcends them all. Perhaps most striking was the integration of artistic and humanistic perspectives into what had initially been framed as a purely scientific investigation. Writers, composers, visual artists, and philosophers were invited to participate in research conferences, to engage with the data and its possible interpretations, to offer perspectives informed by different ways of knowing. This wasn't merely a public outreach effort, but a recognition that phenomena as complex and boundary-challenging as Three-Eye Atlas might be best approached through multiple epistemologies, through ways of knowing that complemented rather than competed with each other. Some realities speak more clearly through metaphor than mathematics. Artists who engaged with the Three-Eye Atlas data often noticed patterns and relationships that had eluded more technically oriented observers. Their training in visual perception, in recognizing emergent forms and subtle harmonies, allowed them to identify structures in the data that analytical approaches had missed. Several significant breakthroughs in understanding the visitor's anomalous characteristics came through these artistic insights, through perspectives that approached the phenomenon not as a problem to be solved, but as a presence to be experienced and interpreted. The eye that seeks beauty sometimes finds truth that precision overlooks. Composers translated the rhythmic patterns detected in Atlas's emissions into audible form, creating musical works that made perceptible to human senses relationships too complex to grasp in numerical form. When researchers listened to these compositions, experiencing through sound what they had previously encountered only as data points, new insights emerged. The temporal relationships, the harmonic structures, the subtle variations that became evident in auditory form suggested patterns of organization that transcended random variation without conforming to known physical processes. Some harmonies reveal themselves only when heard through human hearts. Perhaps this was the visitor's most significant legacy, not what it revealed about the cosmos, but what it revealed about the human capacity to engage with the truly unknown. Throughout the investigation, researchers had been forced to question basic assumptions, to consider possibilities that stretched conventional frameworks to their limits and beyond. This intellectual flexibility, this willingness to follow evidence even when it led into unfamiliar territory, represented science at its most vital, not as a body of established knowledge, but as a method for expanding the boundaries of understanding. To see clearly, sometimes we must first acknowledge our blindness. The Three-Eye Atlas experience had demonstrated both the power and the limitations of human cognition, our remarkable ability to detect patterns, to construct explanations, to revise our understanding in the face of new evidence, but also our tendency to project familiar categories onto novel phenomena, to overlook what doesn't fit our expectations, to retreat into comfortable certainties when confronted with profound ambiguity. The researchers who had engaged most successfully with the visitor's mysteries were those who had maintained a delicate balance between rigorous methodology and intellectual openness. Between skepticism and wonder, true sight requires both the microscope's precision and the poet's peripheral vision. This balance between structured inquiry and creative insight, between analytical rigor and intuitive leap, emerged as a key theme in reflections on the Three-Eye Atlas research. Dr. Sofia Mendes, who had led the data analysis team at the European Southern Observatory, described it as disciplined wonder, an approach that combined methodical investigation with a willingness to entertain possibilities beyond the boundaries of established theory. The discipline keeps you grounded, she explained, prevents you from mistaking wishful thinking for evidence, but the wonder keeps you open to what might be, to signals that don't fit your preconceptions. The most important instrument in any observatory is the mind that interprets what it sees. As years passed and Three-Eye Atlas receded beyond the reach of even our most powerful instruments, its physical presence faded into memory, yet the questions it had raised remained, not just in specialized fields, but in the broader human conversation about our place in the cosmos. Artists incorporated the visitor into their work, creating images and narratives that explored its ambiguous nature. Writers speculated about its origins and purpose, crafting stories that ranged from the scientific to the mythic. Musicians composed pieces inspired by the patterns detected in its emissions, translating mathematical relationships into audible form. Art continues conversations that science can only begin. Visual artists found in Three-Eye Atlas a powerful symbol for the boundary between the known and the unknown, a presence that existed at the edge of comprehension, simultaneously concrete and elusive. Paintings and digital works depicted the visitor not as it had actually appeared in telescopic images, a faint, indistinct blur, but as it existed in the collective imagination, a form that shifted between states, that suggested both structure and fluidity, that evoked both machine precision and organic complexity. These artistic interpretations captured something essential about the phenomenon that technical descriptions could not: its refusal to be reduced to simple categories, its existence at the intersection of multiple possible realities. Images sometimes capture truths that measurements can only approach. Literary responses were equally diverse. Science fiction writers incorporated elements of the Three-Eye Atlas phenomenon into narratives exploring first contact, cosmic mystery, and the limits of human understanding. Poets found in the visitor a rich metaphorical landscape, a way to speak about encounters with the ineffable, about the human experience of confronting realities that exceed our conceptual frameworks. Philosophical essayists used it as a starting point for explorations of consciousness, perception, and the nature of knowledge itself. In each case, the artistic response wasn't merely decorative or entertaining, but a genuine mode of inquiry, an attempt to approach through imaginative means questions that resisted purely analytical approaches. Stories are the vessels we build to navigate seas of uncertainty. Perhaps most striking were the musical compositions inspired by Three-Eye Atlas, works that translated the mathematical patterns observed in its trajectory, its emissions, its interaction with space-time into audible form. These weren't merely aesthetic responses, but attempts to make perceptible to human senses relationships too complex to grasp intellectually. When performed in planetariums and concert halls, these compositions created experiences that went beyond conceptual understanding, allowing audiences to feel something of the visitor's strangeness, its mathematical elegance, its position at the boundary of the comprehensible. Some truths can only be known through the body's response to them. These creative responses weren't mere fancies or embellishments. They represented another mode of engagement with mystery, one that embraced ambiguity rather than seeking to resolve it, that explored the subjective dimensions of encounter alongside the objective. The visitor had affected not just what we know, but how we feel about what we know, had touched emotional and intuitive aspects of human experience that lie beyond the reach of formal analysis. In acknowledging this broader impact, we recognize that genuine understanding encompasses more than data and theory alone. The black swan carries meaning in its form and its silence, religious and spiritual. Communities found in Three-Eye Atlas confirmation of diverse beliefs about humanity's place in a larger cosmic context. For some faith traditions, the visitor represented evidence of divine creation's vastness and complexity. For others, it suggested the possibility of multiple created intelligences, each with its own relationship to the divine. Spiritual seekers outside organized religions saw in the Three-Eye Atlas anomalies support for more expansive conceptions of consciousness, for the possibility that awareness might exist in forms beyond the biological, might permeate the cosmos in ways our materialist frameworks had failed to recognize. That faith finds its greatest tests and deepest confirmations in the same mysteries. The term black swan had persisted in discussions of Three-Eye Atlas, capturing something essential about its significance. Just as the discovery of black swans in Australia had overturned a certainty of European natural history, the visitor had challenged certainties about what moved through the spaces between stars, about how matter behaved at the boundaries of our observation, about the relationship between consciousness and physical reality. It had reminded us that the cosmos remains largely unexplored, that our maps, however detailed, cover only a tiny fraction of what exists. The black swan takes flight not just through space, but through understanding. This metaphor of the black swan resonated beyond scientific circles, entering broader cultural discourse as a shorthand for paradigm-challenging discovery, for observations that force fundamental revisions in our understanding of reality. It appeared in the titles of books exploring scientific revolution, in the names of research initiatives focused on detecting anomalous phenomena, in the language used by educators to describe the process of knowledge transformation. The visitor had become not just an astronomical event, but a cultural touchstone, a reference point for thinking about the limits and possibilities of human knowledge. Some visitors leave their deepest footprints not in space but in meaning. What made the black swan metaphor particularly apt wasn't just that Three-Eye Atlas had been unexpected, but that it had revealed limitations in the frameworks we used to make sense of cosmic phenomena. Just as European natural philosophers had assumed all swans were white because that aligned with their experience, astronomers had developed classification systems and physical models based on the celestial objects they had previously observed. The visitor had demonstrated that reality encompasses possibilities beyond those captured in our existing categories, that the cosmos contains phenomena for which we have no name, no concept, no ready explanation. Categories comfort the mind, but the universe has no obligation to respect their boundaries. This humility before the unknown represents not a retreat from knowledge, but its advancement. Throughout history, The most significant scientific progress has emerged not from the steady accumulation of facts within established frameworks, but from the recognition of anomalies that cannot be accommodated by existing theories. 3i Atlas stood in this tradition, a celestial anomaly that had opened new pathways of inquiry, new possibilities of understanding. Its passage had left us with more questions than answers, but they were better questions, more profound, more consequential, more aligned with the actual complexity of the cosmos we inhabit. Years will pass and new stars will rise, but the story of 3i Atlas will remain, a reminder that even the smallest flicker across the sky can shift our cosmic perspective. As our solar system continues its endless journey through the galaxy, it carries with it not just planets and moons, asteroids and comets, but the accumulated experience of everything that has passed through it, including the brief presence of a visitor that defied easy explanation. Whether 3i Atlas was a natural phenomenon of extraordinary complexity or something designed with purpose and intelligence remains unknown. Perhaps the distinction itself reflects limitations in our thinking rather than reality. What matters most is not the final classification of the visitor, but the doors of perception it opened, the possibilities it revealed, the questions it invited us to consider. Maybe the black swan isn't an omen, but an invitation. The cosmic evening deepens around us. Stars emerge from the darkening blue ancient light, reaching our eyes after journeys of inconceivable duration. We stand beneath this canopy of time and distance, momentary beings contemplating eternities, and somewhere out there, moving through the vast silence between illuminated worlds, something continues its own journey, whether returning to distant origins or proceeding toward destinations we cannot imagine. It passed through our awareness, just as it passed through our solar system, briefly visible, persistently mysterious, forever changing how we see the night sky and our place within its darkened majesty. And somewhere out there, something was still watching.